Here is an explanation for the answer to final exam question number 88 in Physics Demystified, 2nd edition. If you have the printed book, please see page 534. We're talking here about a phenomenon called heterodyning. Heterodyning, also known as signal mixing in radio frequency equipment like wireless transmitters, ham radio transmitters and receivers, citizens band radio, even your FM radio may have this. The phenomenon is called heterodyning or signal mixing. Suppose that we combine a 4.5 megahertz signal and a 2.1 megahertz signal in a mixer deliberately designed to produce signal heterodyning. What frequencies will we observe at the output in addition to these two signals here, 4.5 and 2.1 megahertz? Presumably some of these signals will leak through to the output, but what will we observe in addition? Well, when we mix two signals like this with sound waves, it's called beating. Oftentimes you will hear about beating. And these results of the combining of these two signals by heterodyning or beating are called heterodyne products, or sometimes beat frequencies. Well, those frequencies are equal to the sum and the difference of the two inputs. So we will observe one mixing product or beat frequency at 4.5 plus 2.1 megahertz or 6.6 megahertz. So that's one of the frequencies we'll see here, 6.6. We'll also see a mixing product at the difference frequency, 4.5 minus 2.1. That works out to 2.4 megahertz. So we will see 2.4. Presumably also at this output we will see 4.5 megahertz and 2.1 megahertz. So that's what happens in a device like this. Now, those have specific uses in radio equipment. We can take advantage of either the sum or the difference frequency. In general, the way that this works, the way that a mixer will work in practice, is that we'll have two different signals at the inputs whose frequency can vary. And they vary in such a way that their difference is always the same. So for example, 4.5 megahertz might go up to 4.6, while 2.1 goes up to 2.2, so the difference remains a constant 2.4 megahertz, thereby giving us a constant output frequency, which makes it much easier to process the signal. If you have a signal that you want to process in any various ways, it's a lot easier to do that if the frequency stays the same than it is if the frequency changes on you all the time. So the correct answer to this question is D. We will see two new signals, one at 2.4 megahertz and the other at 6.6 megahertz.